A bigram simply logs the same works for the characters. Instead of using all previous sequences to predict one character, we simplify the task by using only one single character to predict the next character. For example, we use dot to indicate the beginning and the end of the name, and dot C means C is the start of the name. CH means given C, we predict H, and given H, predict R, given R, predict I, and so on and so forth. Notice that we've already made a 2-column prediction model. Since a certain name only have limited number of characters, it has at most 26 characters in the alphabet. So we can turn this 2-column prediction model into a 2-dimensional matrix to lookup table to better visualize the prediction. Andrej gave this lookup table a name called bigram. A bigram is essentially logs all the possible occurrences of all possible pairs in a name. For example, we put dot as the first character, and the first row will start with a dot followed by all possible names. The second will be start with an A followed by all possible names, followed by all possible characters, and so on and so forth. In the first row, dot C is 1, all other elements are 0. That means C is the start of this name. Dot C occurs once. You can see there are several ones and most of the elements are zeros. And those ones are the pairs that's activated in the name. With one name, we'll only see ones and zeros in this bigram. But if we have more names, we can add more occurrences to this bigram. The number will increase, and we will see less zeros and more, bigger numbers. In addition, if we use more name, the bigram will eventually cover all possible characters in the alphabet, and it will have 26 characters plus 1 dot. So this bigram will be 27 times 27 bigram matrix. So Andrej took a data set that has 32,000 names. And with this data set, he was able to build a giant or master diagram, which I can show you here. This is a diagram that logs all the possible occurrence of all the possible pairs in all those 30,000 names. If we zoom in, we can see very rare occurrences like DB or DC, and there are most probable occurrences like A dot and AN. Let's take an example. A dot means it's followed by a 6,640. That means 6,640 name starts with A. And AN is associated 4,530A. That means more than 5,000 times. And A is followed by N. So with this diagram, what we can do, why does this bigram matter? The definition of bigram is it logs the occurrences of all the possible pairs in all the names data set. And occurrences are essentially frequencies. The bigger the number, the more frequent that pair appears in the data set. And we can turn frequencies into probability. For example, what is the probability of predicting n given a letter A? Since an happens around 5,000 times out of all the possible pairs that starts with A, we can calculate the probability of predicting n by just count, divide 5,438 by the sum of all the possible occurrences on this row. That will give us the probability, right? The same works for every other rows. So with this bigram, we're able to just keep predicting next letter by just looking up numbers or probabilities in this table and sample the possible character out of the probability distribution of the one single row. An example would be, all right, let's say it's very likely that n will follow a, right? Now we have letter n. What will come next? Let's turn to the rows that associated with n. This is n row. This is all the occurrences of all possible characters that follow n. The most likely scenario will be, okay, after we predict n, it'll mark the end of the name. Nothing will be predicted. And there's a small chance that n will be predicted twice. And there's even smaller chance n will be followed by e and I, right? And then we can do it again and again until the prediction meets the dot, which marks the end. The prediction will stop. Okay. So in Andrej's code, this is the same diagram that he uses for prediction. And he built a way to predict next token. And if we have run it 5 times, that is the name it actually predicts. But we've seen the power of Bigram. This is essentially a lookup table that encodes all the possible probability of all the pairs, and we can simply by looking at pairs to get the next letter predictability. Next, we will get rid of this bigram and using a network instead to reach to the same probability of prediction power, which will be very fun.